So I finished populating my sound card, and with this last video, specifically on the sound card build, I have added the dual port RAM. So this is dual port static RAM. It allows my 286 to talk to the sound card through that RAM. It also allows my 65816 coprocessor here to write memory and have that go back to the 286. So it's just a way to transfer data between this system and the 286 system, essentially. I also have in the appropriate logic here so that I can do the decoding, so the 286 can work with this card, and this card knows when it should respond to basically information on the 286 bus. I also have a register, and that register is accessed through an I/O address on the 286, and through that register I can trip an interrupt or trigger an interrupt on my 65816. So really at this point I should be good to go. From my 286 I can send commands to the sound card, I can trigger an interrupt on the sound card. Sound card can reverse the direction and it can send data back to the 286 and also raise an interrupt on the 286. And for now I'm going to still leave this little debug screen on here because I'm going to show some stuff that just helps me debug, and I'll kind of show you that code here real quick. So I'm going to go ahead and pop this card in. I will comment that when I did first add the remaining components here, I was having an issue that the system was not behaving correctly, and it ended up that the dual port static RAMs, I had ordered a batch of them. These were inexpensive ones off of AliExpress, if I remember right, and 8 out of 10 of them were not running at the speeds that they were rated. So I'm guessing they were relabeled so that they labeled one thing, but they really were not that speed of a chip. But a couple of them were the ones that really were the faster 55 chips, and those seem to be working fine. So I think I just have a batch of maybe not so great dual port static RAMs, and these are just small 2K static RAMs. I'm not too worried about it, but it did take me a little bit to track down that I had a whole bunch of those that were not processing fast enough. If I put in a slower oscillator for my 286 or for my sound card, then they worked fine. But I wanted to keep the oscillator here on the sound card at 10 megahertz, and that's what I have. So I'm going to go ahead and show you a couple things in code real quick. So here is maybe starting out with the code for the sound card. So I'm going to go over to, this is my sound card code. And at the very bottom, remember this is 65816 code, I have basically a pointer to where my interrupt should be jumping to. So when an interrupt happens on that sound card, this is the label that will basically jump to. And in that label, I'm simply storing a command that I want to do this command 1. And then I get out of this label, and I've got to check. This is from some older code I had, that if it's currently playing a song and you send something to it, it'll just stop the song. I'm not worried about that quite at this point. So basically it comes in, I'm going to load up a command, it's not playing anything, so then it's going to get out of that. But what it is going to do once it loads up this command and it gets out of here, it's going to get back into my normal loop. And in the normal loop for this code, I simply load up the command to process, and if it's a 1, then that means, oh yeah, there's a new command that I need to process or do something with. And I'll come back to this code in more detail later because I've got quite a bit I can do with this, and right now this is a really simple, just make something work type of thing. But the interrupt happens, it marks this command to process with a 1. In my loop label I say, oh yeah, if it's a 1, go ahead and process the commands. And then if I go look at that real quick, I have this actually now on the address of 6000. That's where my basically my dual port memory is at as far as the sound card sees it. And what I do is I read from the dual port RAM. So when this happens, it goes and it reads from the dual port RAM, and it reads from the address of 6002 hex. And in that there should be a number that the 286 wrote to it of what song it wants to play. But it'll read that number, And then once it gets done with that, it's going to print it to the screen here so that we'll see it. And then depending on which one I selected, it's then going to go ahead and really run that command. So maybe let's just say I did a command 5, and command 5 says, okay, here's a pointer to a song on my ROM. And eventually I'll make this more dynamic and be able to have it look this up. But for now, I'm just saying if you send me a command 5, here's where the song is at on my ROM. And I have a little utility that actually builds ROMs for me. I can put all my media together, just say burn it to the ROM. And then it comes back with the addresses of all of the media where it sits. If I take a look at this, then it then actually goes in and it loads up basically pointing to where my song is at, and then it jumps to this continued, and that continued just simply says play from ROM, and that's a routine that as I go look at it is over in a separate file, and that has a lot to it as far as what it's doing. But essentially this is going to go and start reading off the ROM, and then it's going to start setting all the appropriate channels. Remember, there's 3 channels per PSG, and it's going to start setting all those PSGs and their channels to basically play back the song, and it's going to just kind of work its way through the song data that's stored on that ROM file, or on that ROM, which is sitting right up here. But when this sound card first starts up now, if I go back to the initialization code that I have for this, on a reset, here's what I go through and I do. I disable interrupts. I basically get my VIA up and running or configured the way I want it. So I disable all interrupts on this VIA 3, which is one of my 3 VIAs. I initialize my LCD, and then I'm going to call this test DP RAM. And this is a quick little routine I wrote just to simply, from the sound card, write to the dual port memory these values, a 31 and a BD, and then read them back and print them. And that way I know if I see those values on this screen, the dual port memory from the sound card is working, from the sound card side of it. That doesn't mean that from the 286 it's working, but at least within the sound card. So I call that simple little test. And then I initialize sound, and when I do an initialize sound, that is in this other file, I load up, again, some parameters that I send out to each of those PSGs, and it's called AY1 because initially when I wrote this code, it was for the AY chips, not the Yamaha chips, the AY38910. But then these are routines that basically reset those PSGs kind of to a default state that I want them in. And then I simply get into this loop label after I enable interrupts. So essentially this sound card, when it's turned on, when power is applied to it, it's going to do initialization, get the VIA set up, it's going to reset all the PSGs to kind of a state that I want them set to, and then it's just going to jump to this loop label and sit here and wait and spin basically. What's going to trigger it to actually do something is an interrupt, and that interrupt is going to come from the 286 to the register that it writes to on the sound card, which will then set this flag that there is a new command to process. It'll then read from the dual port RAM what song should it play, and then it will play that song. So that's what the sound card is doing for the moment. Now on the 286 side of things, I, in my startup, call a procedure called test sound card. And so from the 286, it's going to go ahead and go out to the 286's memory address, which is B0000. So I put B000 in ES, and I say, okay, go to B0000 and go ahead and write in ABCD into that, and then read it back out, and then go ahead and print out the same thing here, print out the 2 separate bytes of data, but to this screen. So the 286 is going to do a test write and read and print it out, just like the sound card was doing a test write and read and printing it out up here. But that'll just make sure that if I see those characters on these screens, I know that they're both getting to that meet in the middle point, which is the dual port RAM. And then I turn around and I'm going to store the value 6. That's the song number I want it to play. And I'm going to store that at the position of B0002. And then I'm going to go ahead and write an I/O output to that register on the sound card that's going to activate the interrupt. I give it a slight delay, which I don't think I even need, but then I release the interrupt. So the 286 is going to go to the memory, do a test write and read, then it's going to go right to an address that says I want to play song number 6, and then it's going to go ahead and write to the I/O register that says register that interrupt, so that the 65816 on the sound card will then do its processing, and its processing then will look up in address 02, this address right here, the offset, read that value, and then go ahead and play the song that is referenced in that value. Now the addressing used by my sound card to get to that dual port memory is actually part of this address table that is running on the sound card. So it's going to use 6000, and when I'm using that offset of 2, on my 286, that's in this B1000, right? It's B0002, but on my sound card, that same location is addressed at 6002. And the sound card only has a 64K address range versus 1 meg over here. But that allows me then from the sound card to read that value and play that song. So they each see the same dual port memory. Interrupts, I'm going to go ahead and interrupt that way. For the moment, I don't need to do anything with interrupts from the sound card back to the 286, but maybe at some point I will leverage that, and that functionality should all be working. I've not tested that part of it yet, though. So I'm going to go ahead and turn on the system. The things I'm looking for those test characters to show up here on the LCD that goes to the sound card. I'm looking for a different set of test characters to show up on this screen as I'm doing the test write and read to the dual port memory. And on my 286, let me flip back to that for 1 second. This test sound card with the interrupt, where I raise that interrupt, that's going to happen at the very end of my initialization. So at the very top, I go through all this normal boot up stuff I've been doing in my videos. And then the test sound card is just going to happen at the end here. So at the very end, it's going to do the test. So I should see this boot up, go through its normal boot sequence, see my posts, see all that type of stuff. And at the end of it, then it's going to throw an interrupt over to the sound card. In that interrupt, I print which song number was requested, and then I start playing it. And I'm going to go ahead and turn on the system. And so I can see the sound card initialized very quickly. Here my 286 initialized. Here it sent over the 06. Okay, so there what you heard was the song that I chose. I've got a few different songs, or a handful of songs on this flash memory, and I just picked one of them to play. But what you saw was my 286 boot up. The sound card initialized instantly, so it was initialized. I see back the 31BD, and if I look at the sound card code, what I was writing in its initialization was the value of 31BD. And so I get my 31BD, so that looks good. Over on my 286, when it comes to the initialization, I'm writing out an ABCD, and then I'm reading it back in reverse order, but there's my CDAB, so that came back just fine. So those tests, writes and reads to the dual port memory is working fine. At the end of the 286 being turned on, then at the end of the initialization, it then raised the interrupt. It first wrote a 6 into the dual port memory. It raised the interrupt. The sound card got it, processed the interrupt. It read the value from the dual port memory, showed me the value that it read, and then it actually processed that song. So I'm going to go ahead and power it off again. And I'll go through this one more time. So I'm just going to turn it on, and I'll let it just boot up so you can watch that and then hear where this song kicks in. So that gives you the idea that kind of how I'm going to work with the sound card. The nice thing about this is as soon as I trigger that interrupt, the 286 can go back to doing whatever it's doing. So taking other user input, doing other processing, it's doing nothing at that point. The 286, the sound card, sorry, is doing all the work of actually playing back that music. So if, for example, I was working in a game or something, all that background music in the game can be completely offloaded and take up zero processing on the 286. And then sound effects, same thing. They'll all be stored on the sound card. And then I can just simply say play sound effect number 200, and it'll play the sound effect. So very low overhead on the 286 side of things. And then we'll see if later at some point I have a need to even interrupt from here back to the 286. That support is there, but right now I'm not thinking of any big reasons I would need that, other than maybe at the end of a song I would raise an interrupt that says I'm done playing whatever song. So I could see maybe something like that being helpful at some point. So I have a lot running here. Right now I'm just looking at my power being pulled for the entire system. I'm at 1.3 amps for the entire setup here. Both of these cards are being powered off the ISA-bus. I do have supplemental power if I want to use it, but so far it looks like I'm not needing it. I am powering this Nano. I've got a couple screens, well, a few screens here running this Nano. All of that's running off of my benchtop power supply, and it looks like 1.3 amps is where I'm at for all of this. This card probably has as much of a load as the rest of this system. There's just so much on it. This appears to be working. I guess now what I can do is actually get in and start just doing some more coding around sound card and audio stuff. I am going to post a video maybe in the coming week about how I am programmatically working with these sound generators. So I'll give more detail on the sound generators, how they work, how I'm basically controlling them from my 65816 code, and then I'll maybe show off some utilities that I've written, kind of talk through them a little bit. I've got a little simple board here that allows me to use a Nano and put in one of these PSGs and a ZIF, and then I can programmatically control that from Windows software. So I have a little Windows app that lets me programmatically work with one of these PSGs, or take this one out and put in like the AY38910 instead of this YM2149 and see how it behaves. And then in a previous video I showed I have a larger version of that too, where I'm using a Mega to control 6 of them, so I can really test sound effects and whatever I want to do with that. But I've also written software that lets me take MIDI keyboard input. It allows me to import music XML files and really allow me to create music and put them into a format that I can either write to the flash memory or the SD card on my sound card, or I could put it into the 286's storage and transfer it through the dual port memory too at runtime. But I'll go through more of that in detail, so if you're interested in learning more about the PSGs specifically and how I'm controlling them and ultimately getting content for them put together, stay tuned for that. I'm going to guess that'll be a longer video. I'm probably not going to try to break it up. I'll just make one long video for those that want to watch it. And then I'll start trying to tie in audio better into my system overall now.